Imagine a world without sun, a realm of perpetual twilight, then absolute blackness. This is the deep sea. It's the largest living space on Earth, yet more mysterious than Mars. To journey here is to leave the familiar behind. Pressure mounts, darkness deepens, and the rules of life are rewritten. The landscapes are alien, vast muddy plains, jagged mountain ranges, and trenches that could swallow Everest. Volcanoes and chasms shape a world where time drifts with the slow fall of marine snow, organic debris feeding life below. The rocks and mud here are archives of Earth's history, holding secrets of ancient climates and life. This is Earth's final frontier, untouched, unmapped, and largely unknown. For centuries it was a place of myth and monsters, a void on our maps. Now we see it as a place of immense possibility and profound mystery. It is a world that has existed in perfect dark isolation for millions of years, but that isolation is about to end. The silence is about to be broken. We stand at its edge, peering into the gloom with our robotic eyes. What we find here could change everything we know about our planet, but at what cost? In the crushing dark, life flourishes with breathtaking ingenuity. It makes its own light. This is the realm of bioluminescence, a living language spoken in flashes of cold fire. Anglerfish dangle glowing lures, vampire squid unfurl sparkling cloaks, and swarms of tiny crustaceans shimmer like living galaxies. These are not monsters, but marvels of evolution, each a unique solution to life in the abyss. Around hydrothermal vents, life thrives in toxic darkness. Giant tube worms, blind crabs, and strange fish, all powered by chemosynthesis, not sunlight. This discovery changed our understanding of where life can exist. The deep sea's web of life is delicate, developed over millions of years in stable darkness. These creatures have never known the roar of engines or the churn of machines. Their existence is a fragile miracle, and it is this miracle, this quiet, luminous world, that we now risk for our own needs. The question is not just what we will find, but what we will lose. Are we ready to pay that price? On the surface, our world is in peril: rising temperatures, melting glaciers, and extreme weather. The Green Revolution promises a cleaner future, powered by sun, wind, and batteries, but this future is hungry for metal, cobalt, nickel, rare earths, and copper. Our quest to save the planet's surface is creating unprecedented demand for these materials. To meet it, we turn to the world of eternal night, the deep sea. Can we call a solution green if it means strip mining a pristine, ancient ecosystem? The green transition is not a cure, it's a resource shift. We're swapping one dependency for another, justifying a new frontier of extraction with the language of environmentalism. The deep sea is simply the next target. We must ask, is this progress or just repeating old mistakes in a new place? What are we willing to sacrifice for a green world? Scattered across the abyssal plains lie the treasures we seek, not gold, but potato-sized polymetallic nodules. These nodules, formed over millions of years, are rich in the metals our green revolution craves: manganese, nickel, cobalt, copper, and rare earths. They sit unattached on the sediment, a carpet of mineral wealth. Around hydrothermal vents, massive sulfide deposits form chimneys rich in copper, zinc, gold, and silver. Cobalt-rich crusts on underwater mountains offer yet another concentrated source. On land, ore grades are declining and mining is ever more destructive. The deep sea appears to offer a purer, more accessible source. Proponents argue deep sea mining could be cleaner and more efficient, reducing the burden on land. The allure is undeniable, a cleaner path to a cleaner future, but the promise comes with a catch. These resources took eons to form. Their removal could erase ancient history and life. Is this truly a cleaner solution or just a new kind of risk? The answer lies in the depths. The demand for deep-sea metals is woven into the future we're building. Electric vehicles rely on lithium-ion batteries, which need nickel for energy and cobalt for stability. Wind turbines depend on rare earth magnets, neodymium and dysprosium, to convert wind into power. Solar panels, power grids, and energy storage all require vast amounts of copper, silver, and more. Every step away from fossil fuels increases our hunger for these critical minerals. Supply chains are concentrated: Congo for cobalt, China for rare earths, raising ethical and security concerns. The deep sea in international waters represents a new unclaimed source. For many nations, it's not just about the environment, it's about independence and security. The metals of the abyss could redraw the global resource map. But at what environmental cost? The stakes are high and the choice is complex. Can we build a green future without sacrificing another world? Mining the ocean floor requires robotic behemoths, giant collectors crawling across the abyss, vacuuming up nodules and churning the sediment. These machines are tethered to surface ships, pumping nodules, mud, and water up for processing. The scale is staggering: thousands of square kilometers scraped clean, millions of tons harvested each year. This is not delicate work, it's industrial strip mining in the deep. Delicate ecosystems formed over millennia are obliterated in moments. The noise and lights disrupt creatures adapted to silence and darkness. The physical presence of these machines is just the beginning. They are harbingers of a far more pervasive threat. The deep will never be the same. Is this the price of progress? The greatest threat may not be the mining itself, but the clouds of sediment it creates. As machines churn the seafloor, dense plumes of silt drift for miles, smothering life far beyond the mine. Filter feeders are choked, habitats buried, and entire ecosystems disrupted. Wastewater discharged at mid-depths creates even larger plumes, threatening the twilight zone teeming with life. Sediment can clog feeding structures, disrupt thermal layers, and introduce toxins. These plumes travel vast distances, their impact impossible to contain. The damage could span entire ocean basins, crossing borders and generations. Scientific uncertainty clouds every step. We risk unleashing a slow-motion disaster we cannot control. Is this a risk we're willing to take? The deepest cost may be extinction species lost before we even know they exist. Many deep-sea creatures are found nowhere else mining could erase them forever. We are preparing to destroy ecosystems we barely understand. The loss would be silent, permanent, and largely invisible. Nodules take millions of years to form. Once gone, their habitats vanish for good. Recovery, if possible, would take millennia. The deep sea holds secrets to life's origins and future medicines. By mining, we risk erasing this knowledge for a few decades' supply of metals. We are trading unknown wonders for short-term gain. Is this a price humanity should pay? We stand at a crossroads, descend into the abyss for metals, or choose restraint. One path offers technological salvation, but at the cost of a pristine world. The other demands a rethink, recycling, durable design, and new materials. The choice is not simple. Climate change above, irreversible damage below. We must weigh which loss is more bearable. The Green Revolution's hunger for metals pushes us toward this fragile wilderness. The question, what will we sacrifice for a green world? Is the destruction of Earth's last untouched wilderness a price worth paying? Or is it the ultimate failure of our imagination? The silence of the deep awaits our answer.